Okay, in this video, we are going to look at some of the properties of determinants and how these properties are applied in evaluating determinants. So let's start. The first property, it says if all the elements of a row or column of a determinant are zeros, then the value of the determinant itself will be zero. So if you have got a determinant where all of the elements in a row or in a column are zero, its value is going to be zero. So for example, if I have a determinant like this, determinant 3, 4, minus 2, 0, 0, 0, you can see that the second row is completely zero, so the determinant value will be zero. That's because when you expand this determinant using R2, it's going to be 0 times its minor everywhere. And that's how the value is 0. In the second example, I have all the elements of the first column are 0. So the determinant value is 0. So that's your first property. If you ever get a determinant with all the elements of a row or all the elements of a column are 0, then the corresponding value, the value of the determinant, is going to be 0. We look at another property now. If the corresponding elements of any two rows or any two columns are identical, which means they are the same, or if they are proportional, the value of the determinant will be 0. So what's that again? If there are two rows or two columns of a determinant are identical, they are exactly the same. I have ABC in a row, I have again ABC in another row. Or if they are proportional, which means I have ABC in one row, I have 3A, 3B, 3C in another row, then the value of the determinant is 0. So as an example here, I have got a determinant in which the second row 2, 3, 5 and the third row 2, 3, 5, the corresponding elements of those two rows are exactly the same, 2, 3, 5, 2, 3, 5. So the determinant value is going to be 0. Another example, here I have another determinant where the first row is 5, 3, 4 and the second row is a multiple of it. They are proportional, the elements are proportional. 5, 3, 4 and this is 2 times 10, 6, 8. It's proportional. One row is a multiple of the other. Then we say the determinant value is 0. So it's also applicable to columns. So if any two rows or any two columns of a determinant are 0, the value of the determinant is going to be 0. The third property, in a determinant, if any two rows or columns are interchanged, then the value of the determinant becomes negative of the original. So if I interchange two rows or if I interchange two columns, the value of the new determinant will be negative of the value of the original determinant. So example, if I have a determinant like this, and if I decide to interchange two rows, I take R1 and put it in R2's place, and I bring R2 to R1's place, interchange between R1 and R2, it's going to be negative of its original value. So if the value of the first determinant was 10, after this interchange of rows, the value would be negative 10. The value becomes negative. So you interchange any two rows or interchange any two columns, the value of the determinant will become negative of the original. Another property, if any row or column of a determinant has a common factor, it can be taken out of the determinant. Now this is different from your matrices. In a matrix, you can bring a common factor out only if it is common with every single element. But this is a determinant. And in a determinant, we say if a row has a common factor, it can be taken out. So like in this determinant, if we see the first row has a common factor x, so it can come out. The second row has an x common everywhere, so it can come out. The third row has a y common, and so it can come out. So what I get out of this determinant is going to be an x from the first row, an x from the second row, and a y from the third row. So that brings x squared y common factor out. So if x is gone out from the first row, it is 1, 2, 3, what is left there. And if x is gone from the second row, then it will be 4, 5, and 6 there. 4, 5, and 6. And if y is gone out of the third row, it's going to be 7, 8, and 9 there. But then I also realized that the third column has a common factor as well, 3. So also a 3 comes out. So it's going to be 3x squared y. And since I am taking it out of the column, I write them column wise. 1, 4, 7, 2, 5, 8. Those two remain the same. And I brought the common factor out of the third column. So 3, 6, 9 become 1, 2, and 3. So that's how you take common factors out of a determinant. But remember, in a matrix, you couldn't have done that. In a matrix, you can bring a common factor out only if it is common with every single element. Another property, if to any row or column of a determinant, if a multiple of another row or column is being added, then the value of the determinant is unaltered. The value won't change. The value of the determinant is not changed. Means I could have an operation like R1 changes to R1 plus twice R3. Or I could say R1 changes to R1 minus twice R3. Or I could say R1 changes to R1 plus negative 5 times R2. A multiple of a row can be added to another row. An extended result is like I could say R1 changes to R1 plus R2 plus R3. To one row, I could add the other two rows. Basically, add all the rows together. Add up all the rows together. R1 changes to R1 plus R2 plus R3. To one row, I could add the remaining rows. So these are properties which are applied on rows. It could also be applied on columns. So the value of the determinant is unaltered by doing this operation. So this is another property, the same property done in a different way. R3 changes to R3 minus twice of R1. So these kind of properties. We are going to try a few questions where these properties are being applied. So I'm going to pick up a few questions which are either broad questions or some important questions. You will get the idea as how to go about these kind of questions when we do a few questions. Initially you may find it difficult, but you will get used to it. So look at this question. It says using properties of determinants. All these questions are supposed to be like applying properties of determinants, not directly expanding. If you directly expand this determinant, you could still get the answer probably that way, but the question is testing you on applying properties. Apply properties, using properties, prove this result. So I'm going to copy the LHS first. Copy the LHS, copy row wise, second row, and now finally the third row. The first thing which we would try in all these questions is by adding all the rows together or by adding all the columns together. We'll see if we can get a common term throughout a row or throughout a column. Although I said adding all the rows together or adding all the columns together, we try and get a common term throughout a row. It could also be along a column. I could add all the columns together and see if I can get a common factor. I'm going to try row first. To the first row, if I try to add the other two rows, for example, here I have A minus B minus C, and I add the other two rows there, which means 2B will go there and 2C will go there and get added up. So A minus B and 2B will make it plus B, minus C and plus 2C will make it plus C. So I'm going to get A plus B plus C there. And this 2A and minus A will make it A. Then B I have, minus C and 2C will make it A plus B plus C. Here again there is 2A and there is a minus a coming from R3. There is 2b getting added there, but there is a minus b coming from here, makes it plus b, and then there is a plus c coming from R3. So R1 is going to be a plus b plus c. So that's the first operation I figured out. And that's a common thing which we would always try in any question. So R1 changes to R1 plus R2 plus R3. To the first row, we add the other two rows. So A stays the same. Minus B and plus 2B makes it plus B. Minus C and plus 2C makes it plus C. Here I have 2A already, but there is a minus A coming from R2, which makes it A. I have a plus B coming from R2. Then I have minus C and plus C together, making it as plus C. So A plus B plus C. Here I have minus A coming from R3 and making this 2A into A. This 2B and minus B from R3 will make it plus B, and then there is a plus C coming up from R3. So I get A plus B plus C, A plus B plus C, A plus B plus C in the first row. So the operation was R1 changes to R1 plus R2 plus R3. Now we copy the second row and the third row exactly the same without any change. So I keep R2 the same and R3 the same. Now this A plus B plus C, since it is common, I take it out of the determinant. And so I have, if A plus B plus C is gone out, it's 1, 1, 1. Then we copy R2 the same and R3 the same. No changes. We only took A plus B plus C out of the first row. Now once you have 1, 1, 1, this is again going to be a standard approach. You will retain the first one and make the other two ones into zeros, which means I want a 0 here and I want a 0 here in this place. And they all belong to the same row, so your operation is going to be column wise. So if I want 0 here, 1 minus 1 will make it 0. So I'm going to say my operation is going to be C2 changes to C2 minus C1. And I want 0 here, so that is C3 changes to C3 minus C1. So the operation is going to be C2 changes to C2 minus C1 and C3 changes to C3 minus C1. So when I do column wise operation, I also write it column wise. I'll keep ABC outside into determinant, and then I copy my C1 as it is, because C1 is not under change. What is not under change, you could copy that first. So I copy 1, 2B, 2C, this same. Now we do C2 minus C1. Corresponding elements you subtract. 1 minus 1, 0. I got it already here. Now this B minus 2B is going to be minus B. You already have minus C, you already have minus A, which means this is going to become minus A, minus B, minus C. Once again, when I subtract C2 from C2, when I subtract C1, B minus 2B is minus B there, then I have a minus C and minus A. So it's going to be minus A, minus B, minus C, then 2C minus 2C is 0. Now C3 minus C1, 1 minus 1 is 0, 2B minus 2B is 0, C minus 2C is minus C, C minus 2C is minus C, minus A minus B will stay the same. And then we will expand it using the first row. So when you expand it, A plus B plus C into 1 into that's delete the row. How do you expand it? You delete the row and the column it contains. So 1 into cross multiply, 1 into its minus. So it's only between these four elements. Cross multiply, minus of A plus B plus C into minus of A plus B plus C is A plus B plus C the whole square. Minus of A plus B plus C, here it is. And this is also minus of A plus B plus C. So when I cross multiply, minus into minus is plus. A plus B plus C into A plus B plus C is A plus B plus C the whole square minus 0, which is going to make it A plus B plus C into A plus B plus C. That's A plus B plus C the whole cubed, which is the RHS. So we proved it. So what you need to do is you should go back, you should copy the question, and now you should try to do this question on your own and then play it and see whether you have done it the right way. and the most efficient way. We're going to look at another question. Using properties of determinants, prove that, so I have a determinant here is equal to 9 times 3xyz plus xy plus yz plus zx. Okay, I'm going to copy the LHS and then I'll start analyzing the situation. So I copied the LHS, I copied the first row, the second row, the third row, and I start analyzing. I already see that I have 1, 1, just the third element, it's 1 plus 3x. So there is a small change, but I can see there is 1, 1, 1 coming. And usual approach is like you keep the first one and make the rest into zeros. So I can get a 0 here. I can't get a 0 here, but I can get rid of that 1 from there. So my aim is going to, try and make zeros in the remaining places. So I'm trying to do that. I will keep the first element 1 the same. I want 0 here and I want 0 here. Although I can't get the entire term 0, at least that 1 will go to 0. So my operation is going to be C2 changes to C2 minus C1 and C3 changes to C3 minus C1. So from C2 I will take away C1 and also from C3 I will take away C1. C2 minus C1 and C3 minus C1. So let's do that. So when I do that, I'll copy my C1 as it is first and then carefully subtract C2 minus C1. 1 minus 1 is 0. Here 1 minus 1 is 0. See, I have a 1 here in C2, minus 1 from here makes it 0. But I have to also subtract 3y. So 0 minus 3y is going to be minus 3y. Here, the third element, 1 plus 3z minus 1 will get me 3z there. 1 minus 1 is gone, so 3z. Now from this element, C3 minus C1, when I do 1 plus 3x minus 1 will get me just 3x there. 1 minus 1 is gone, 0. 0 minus 3y, because I need to also subtract 3y. So 1 minus in brackets 1 plus 3y. From 1 I am subtracting 1 plus 3y. 1 minus 1 is 0, minus 3y is minus 3y there. And 1 minus 1, the third element, is 0 there. I realize what the trouble now is. I don't have 1, 0, 0 like how we had in the earlier question. So I want to have 1, 0, 0. So if I want one more 0 here, from 3x, if I subtract 3x, it will become 0. So I need to come up with an operation for that. I'm going to copy that part one more time here, what I did already. Okay, now I want this element's 3x to be 0. So what I'm going to do is from 3x, I need to subtract 3x. How do I do that? C3 changes to C3 minus, this is 1 here in C1, but I want to subtract 3x minus 3x. I want 3x minus 3x. So what do I do? C3 changes to C3 minus 3x times C1, because this is just 1. I want 3x there, not really here. I want 3x minus 3x. So I say C3 changes to C3 minus C1 into 3x. C1 into 3x. In C1, I take 3x times C1 and subtract from C3. So the change is happening only to C3. I should copy my C1 exactly the same, C2 exactly the same. Now I do carefully. 3x minus 1 into 3x. 3x minus 1 into 3x. Because it says C3 minus C1 into 3x. C3x minus 1 into 3x. 0. 3x minus 3x is 0. The next one, minus 3y minus 3x times what I see here. It's a little bit confusing for me, so I'm going to do it outside. This element is 3y minus 3y minus 3x times 1 plus 3. 3x times 1 plus 3y. And then I open the bracket with minus 3y. So I get minus 3y. Minus into my plus is minus. 3x into 3y is 9xy. So this is what I have here. So that big term will come here. So let me write that. And then again I have one more subtraction, 0 minus 3x times c1. 0 minus 1 into 3x. 0 minus 3x is minus 3x. So 0 minus 3x. So which should be minus 3x there. So now that I have 1, 0, 0, you could expand it. So you say 1 into expand. How do you expand? It's minor. So when I say 1 into, it's minor. These 4 elements. Minus 3y into minus 3x. Minus 3y into minus 3x. 9xy minus 3z into the other product. 3z into that much. Then you multiply it in and that's your answer. So 9xy, open the bracket, plus 9zy, 9xz, 27xyz. There is 9 common factor and you get your RHS. Another possible simplification was you could have taken a 3 common factor from C2 and a common factor 3 from C3. When you try it, you could try that way. It will become more efficient when you do that way. But it didn't really affect my calculation much. That's why I thought it was okay. But it's possibility that you could take a 3 out of C2 and a 3 out of C3. And that's your RHS. So you can see that there is a standard approach in doing these questions, although every question is going to be in a different way. Third question. Evaluate using properties of determinants. So there is a determinant given to you and your question is to evaluate, find the value of this determinant but using properties of determinants. So that means we are not going to directly expand this. Okay, what I notice here is, or rather what I want is, like I need a 0 or the term should become smaller so that I can expand it. When I look at this question looks totally different, the rows. Okay, if you look at this very last term here, I have a minus sine alpha there and this is cos alpha. You already have a 0 in between, so don't worry about R2. So my worry is about R1 and R3 and see if I can get more zeros. I can see something, this is minus sine alpha, this is cos alpha. So maybe think of LCM and try and make both the same. What's the LCM of sine alpha and cos alpha? Sine alpha, cos alpha. So I want sine alpha, cos alpha in the first row here. It's only cos alpha. I want sine alpha, cos alpha. Oh, it's only sine alpha, but I want sine alpha, cos alpha. So how about multiplying R1 by cos alpha and R3 by sine alpha? So I will have minus sine alpha, cos alpha there and plus sine alpha, cos alpha there, and then maybe then I can try and add. It's a different way of thinking this time. So it's a possibility. So I multiply R1 by cos alpha and R3 by sine alpha, but you're not allowed to do that. If you do that, the value will change. So that's why, if you notice, I have a 1 by sine alpha, cos alpha outside. Because you are going to multiply the first row by cos alpha, so divide by cos alpha. If you are going to multiply R3 by sine alpha, also divide by sine alpha outside. Because when you multiply a row by a number, the value changes. So to compensate, outside you divide. So R1, the first row is being multiplied by cos alpha. So to compensate, I have a 1 by cos alpha outside. And then I will multiply R3 by sine alpha. So to compensate, I have a 1 by sine alpha outside. So that is 1 by cos alpha sine alpha into. The first row is being multiplied by cos alpha. You know the logic, because this will become sine alpha, cos alpha. So when I multiply by cos alpha in the first row, this will become cos square alpha, cos beta. This will become cos square alpha, sine beta. And this is minus sine alpha, cos alpha. R2 we are going to copy the same because we had already a 0, so we were happy about the second row, so I copy the same. But in R3 I want sine alpha, cos alpha, my LCM. This is only cos alpha, so I decided to multiply R3 by sine alpha. So what does it become? This was sine alpha, cos beta, so that's going to be sine square alpha, cos beta, sine square alpha, sine beta, and sine alpha, cos alpha. Now I know if I add the two rows together, like R1 changes to R1 plus R3, I'm going to get one more 0, and also some other simplification is happening. Outside you have this 1 by sine alpha cos alpha. When you add the two, do you notice what is happening in R1? So cos square alpha cos beta is added with sine square alpha cos beta. So cos square alpha cos beta plus sine square alpha cos beta. So don't you have a cos beta common factor? What is balance? Cos square alpha from there plus sine square alpha from R3. So don't you get cos beta into cos square alpha plus sine square alpha, which is 1. I saved a step. Maybe when you copy it down, you could write in detail. And when you look at the next element, cos square alpha sine beta plus sine square alpha sine beta. What is common? Sine beta is common. So you get sine beta into cos square alpha plus sine square alpha, which again becomes 1. So sine beta into 1. And this is minus sine alpha cos alpha plus sine alpha cos alpha makes it 0. Then the second row remains the same. Third row remains the same. Now that I have a common factor, sine alpha cos alpha from C3, I want to bring it out, so it will become 0, 0, 1, and I have that sine alpha cos alpha coming out. So I'm just copying it before I do that. So this is what I had from before, and I'm going to bring the common factor from C3 out. C3 has a common factor because it is 0, 0 sine alpha cos alpha, and I brought that sine alpha cos alpha out from C3 divided by sine alpha cos alpha. This is first column I copy, the second column I copy, and the third column will be 0, 0 and 1. Outside terms sine alpha cos alpha and sine alpha cos alpha will cancel, and then I am going to expand it using C3. So when I expand using C3, 1 into the 4 elements, the minor which you get by deleting the row and the column, just these 4 elements cross multiply, cos square beta minus sine square beta. But minus minus becomes plus. So you get cos square beta plus sine square beta, which is 1. So what you need to do is, we just did only 3 questions. You need to go back, copy down those questions, try and do this yourself. And if you forget the steps, if you get it wrong, then watch it again and make the correction and practice them. Do it many times. In the next video, I'll be doing more questions on determinant proving. So learn the properties, practice these 3 questions properly.